Here's problem 1922. Suppose the ends of a 30-meter long steel beam are rigidly clamped at 0 degrees Celsius to prevent expansion. The beam has a cross-sectional area of 30 square centimeters. What force against the clamps does the beam exert when it is heated to 40 degrees Celsius? The linear coefficient for steel is 1.1 times 10 to the minus 5 per degree Celsius, and Young's modulus for steel is 20 times 10 to the 10 pascals, newtons per meter squared. All right, let's imagine what's going on here. We have a beam, and it's actually trying to expand, but it's been clamped at both ends. So what's happening is it's exerting a force on one end over some kind of cross-sectional area. So I have an area here and a force. Also, it's expanding by linear expansion. So we have some kind of original length here. And then we have a change in length as well. What's given in the Prob is our original length of 30 meters. We're also given the area, cross-sectional area of the beam, which is 30 square centimeters. So that would be 30 times 10 to the minus 4 meters. And we're given our change in temperature, which is going to be 40 degrees minus 0 degrees, or 40 degrees Celsius. So we can calculate what our change in length will be due to linear expansion. That is going to be alpha L naught delta T. So that would be 1.1 times 10 to the minus 5 times 30 times 40. So our change in length is going to equal, let me figure this out, 0.0132 meters. Alright, those are our basic variables. But we're given Young's modulus, and if we recall from Physics 1, Young's modulus is equal to the stress over the strain, the cause over the effect in relation to this static problem. The stress, in turn, is equal to the force per area in a linear sense, tensile sense, and the strain is our change in length over the original length. So we know a lot of these variables. We can use this to solve for the force that is acting in a tensile direction or along the length of the beam. So multiplying both sides by the strain and multiplying both sides by the area, we would get that the force is equal to the strain, change in length over original length, times the area, times Young's modulus. So this is going to be equal 0.0132 meters over 30 meters times the cross-sectional area, which was 30 times 10 to the minus 4. Could just say 3 times 10 to the minus 3. Young's modulus is 20 times 10 to the 10. Everything in the SI system. So what does this give us? I get 264,000 newtons. Or we could say 2.64 times 10 to the 5 newtons. 264,000 newtons, which is a lot of force, which might be enough to bend the beam and cause some major problems. But that's our answer, 264,000 newtons.